Hello! I'm guessing you learnt about transformations at school sometime and you have just forgotten about them. So this video is a reminder for you. So first of all, we have four types of transformations that are going to be covered in this video. We have reflection, we have translation, we have rotation, and finally we have enlargement. Okay, let's just recap that then. So we have a reflection, translation, rotation, and enlargement. So the online exercise comes in a number of different levels, and what you have to do is click on the points where you think the corners or the vertices of the transformed shape would be. You click on those in order and automatically those points get joined up, and then you can click the button to check your shape. If you really get stuck, there's a button that will just show you the answer, or if you think you've made a mistake, there's a button that you can start again. So let's have a look in detail at each of these transformations. Okay, let's look at some examples from level 1. And these are all reflections. So we have to take the shape and in this case reflect it in the y-axis. Well, the y-axis is that vertical line there. You can see it's labeled y. So every point on this shape must be the same distance to the right of that line as the original point is to the left. So for example, this top left point here is 2 squares to the left of our mirror line. So the reflection will be 2 squares to the right. Then this point here is 2 squares to the left of the mirror line, so our reflection will be 2 squares to the right. Now I'm putting big blobs on here with this felt pen. You of course would use a very sharp pencil to get nice, accurate, small points which you would join up with straight lines using a ruler. Anyway, this point here is just 1 square to the left of the mirror line, so we're going to put the reflection 1 square to the right. This is 2 squares to the left, 2 squares to the right. So as I join these up, and you would do this with a ruler, you can see that this point is actually on the mirror line, so its reflection will be on the mirror line as well. And this point is on the mirror line, so its reflection will be on the mirror line too. So that is our reflection. This shape needs to be reflected in the x-axis. The x-axis is the horizontal axis here. So let's start at the top left. This point here, if we go straight up to the mirror line, it's exactly 1 square below it, so the reflection is going to be 1 square above it. This one, 2 below, will go 2 up. This one, 2 below, will go 2 up. And this one, 1 below, so we'll go 1 up. So already I've got part of my reflected shape here. Now let's look at this point. It's 1, 2, 3, 4 squares below the x-axis, so we'll go 1, 2, 3, 4 squares above the x-axis to there. And then this point is going to end up here. So my reflection, the image after being reflected in the x-axis, looks like that. Now this shape is going to be reflected in the line y equals 1. That means the line that goes through all the coordinates that have a y value of 1. Well, y is 1 is on the y-axis here, so all of these points have got a y value of 1. So what I'm going to do is take a ruler and I'm going to draw the mirror line through y equals 1, like that. And now every point on my hexagon has to be reflected in this red line. So the bottom point is 1 square above the red line. We'll go 1 square below the red line. This one is 2 squares immediately above it. So we'll go 2 squares below. That's 3 above. We'll go 3 below. And already I can see the hexagon taking shape. The reflection looks like it's going to go to there, 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 and there. So that is my reflected hexagon in the line y equals 1. This shape has to be reflected in the line x equals minus 1. X equals -1 is all the points that have an x value of -1. So looking on my x-axis, there's -1. I'm going to draw a mirror line that goes through there. So the mirror line cuts through the shape. That's interesting. But we still have the same rule. So let's start off with this bottom left point here. That's 2 squares to the left of the mirror line. So we want to go 2 squares to the right of the mirror line. Then I'll go up to here. That is 2 squares to the left of the red line. I want to go 2 squares to the right. So I can see that one side of my shape is here. You of course use a ruler to join those up with a nice thin line, not like my thick line here, but that's just so that it shows up on your video. So then I can see the shape goes in by 1 square, and then it goes up, and that point is reflected to here, and then the next point is this one here, which is reflected to here. So my reflected shape looks like this. And I'll colour it in, or shade it in very roughly. It looks like that. That is the reflection in the line x equals -1. And then finally for this level, we're going to reflect this shape in the line y equals x. Now that is the straight line that goes through all the coordinates, all the points, where the x and the y values are the same. So for example, it will go through the point 1, 1. It will go through the point 3, 3. It will go through the point -2, -2 down here. So can you see that it's going to be a diagonal line that goes through the origin and goes through all of these points where the x and the y values are the same. So I'll join them up with a red line. That's my mirror line. And then I will start doing my reflection. Now let's start off with this point here. What we have to do is see how far that point is from the mirror line. Now a common mistake is to think that you say, oh, it's 3 squares away from the mirror line. But that point isn't the closest point on the mirror line to this point here. In fact, the closest point is if you go directly towards the mirror line here, going directly towards so that this line is perpendicular to the red line. The shortest distance to the mirror is I can see 1.5 diagonals to there. So that point is 1.5 diagonals away from the mirror down here. So carrying on in the same direction, if I do 1/2 and 1, that's going to go to there. So that top point ends up there. So let's try this point here now. I go directly to the red line by the shortest distance, not that way or not that way, across here. So it is 1, 2, exactly 3 diagonals away from the mirror. So I want to go 1, 2, 3 diagonals up to here. So I can join up these 2 points. That's one of the sides of the image that I have found. Now I'm going to come down to this bottom right point here. This is a bit more tricky. It's 1, 2, 3, 4.5 away from the mirror. So a half, and then 1, 2, 3, 4. It's way up here. So another edge of my image is that line there. So I've done that one. Now I'll go to this one. Remember, go to the shortest route to the mirror. 1, 2, 3.5 diagonals. A half, 1, 2, 3. It is there. Join that up. Now I'm coming to this point way inside here. That's 1, 2, 3 exactly to the mirror. 1, 2, 3 to the image. Join that up. And then this point down here is 1, 2.5 to the mirror. A half, 1, 2. It should be here. And then finally, it doesn't take a rocket scientist to work out that we're going to end up with our reflection looking like that. Okay, have a go at the online exercise. Don't forget to click the check button to check if you're doing the transformations correctly. And when you've finished reflections, come back here for level 2. Okay, we're now at level 2. And this time our transformation is called a translation. And for a translation, we're given a vector. This is called a vector. It's a bit like coordinates, but can you see the numbers are written vertically inside the brackets? And this, quite simply, means that this shape is going to go 3 squares to the right and 5 squares up. That's like the x and the y displacement. So 3 squares across to the right and 5 squares up, x and y. So let's start with the top right point. 1, 2, 3 squares across. 1, 2, 3, 4, 5. The top right point is going to be here. Now let's look at this point. 1, 2, 3 across. 1, 2, 3, 4, 5 up. It's going to go to there. And remember, you should be using a nice sharp pencil for this, not a big thick felt pen like me. Right, this point here, 1, 2, 3 across, 1, 2, 3, 4, 5. So that's going to go to there. And then the bottom right corner here, 1, 2, 3 across, 1, 2, 3, 4, 5. That's going to go to there. And I can see the shape. It's going to be the same way round up here. So I think I can very quickly finish it off. I can see that this left side has got a height of 3 squares, so I can go up 1, 2, 3, and this top has got a width of 2 squares. So that is the translation after a movement of 3 to the right and 5 up. Okay, let's have a look at another example of a translation. And here we have a hexagon, and we have to show the image of that shape after a translation by the vector 3. That means 3 to the right, and that means minus 3 up. Well, another way of saying minus 3 up is 3 down. So it's 3 to the right and 3 down. So let's start off with the right hand side. 1, 2, 3 to the right and 1, 2, 3 down. That's going to go there. 3 across and 3 down. Then that point is 1 underneath it. So 3 across and 3 down is no surprise, it's going to come to here. And then very quickly you can see how this image is going to take shape. You could check 3 across and 3 down. Yes, I'm drawing it correctly. So the image is here. The same way around, but just in a different place. Okay, let's try another one. And this one, we're going to have to translate it minus 3 to the right. Well, another way of saying minus 3 to the right is 3 to the left. And that means 2 down, as you know. So 3 to the left and 2 down. So let's start at the bottom here. 3 to the left, 1, 2, 3, and 2 down, 1, 2. Then this point here, 1, 2, 3, 1, 2. Then this point here, 1, 2, 3, 1, 2. So that's the bottom of the shape there. And then I can see this one slopes up with a gradient of 2. So I could just draw that in. And I could see this one slopes up with a gradient of 1/2. So I could just draw this one in here. And then let's just check this one to be on the safe side. 3 to the left, 2 down. 1, 2, 3 to the left, 1, 2 down is there. So join that up to there. And then finish off the shape with a vertical line here. So my image after a translation of -3, -2 looks like that. Okay, have a go at level 2 of the online exercise. Press the check button regularly to see if you're getting them right, and then come back here for level 3. And now level 3 of this transformations help video. And this time the transformation is a rotation. We're going to rotate this shape 90 degrees, that's like a quarter of a whole turn, about the origin, that's where the two axes cross, in a clockwise direction. That's the same way that the clock goes round. Now the best way to do rotations is with the help of a bit of tracing paper. And what you do is you trace the shape as accurately as you can. And then you mark where the center of rotation is. Well, it says here the origin. So I'm going to put a little red dot to show that we're going to rotate this about the origin. And what I like to do is somewhere else on the tracing paper put a little arrow showing which direction is up, just in case I forget when I start rotating. And then what you want to do is to put your pencil firmly on the center of rotation, and holding that down, rotate it by 90 degrees clockwise. So I'm going to turn the tracing paper around, and I can see that my red arrow, when my red arrow is pointing exactly to the right, then I must have done exactly 90 degrees. That's a quarter turn. So now I can release. Careful the tracing paper doesn't move. And now I can see where the image is going to be. It's going to look like that. I've got to transfer that to my paper. Now one little trick you could do is take maybe a ballpoint pen and then press hard on each of the points so that it makes a little impression on the paper underneath. Has it done that? I can see there's a point there, and there's a point there, there's a point there. Yes. So now you can get rid of the tracing paper and you can just go over those points to see where the image will be. So joining them up like this, I can see that my image is going to look like that. And that is a rotation of 90 degrees clockwise about the origin. Okay, it's quite straightforward if you have the tracing paper. So to do this online, obviously you can't very easily use tracing paper on a computer screen. So what I recommend that you do is you make a copy of the diagram on paper, do the rotation on paper, and then just copy your answer to the screen version. Right, let's have a look at another example here. I'm going to use the same piece of tracing paper, and what we have to do is rotate this one 180 degrees clockwise about the origin. So I'm going to put this over, where shall I do it? Let me do it maybe this side, and making the most of my paper here. So I'll get my arrow pointing directly upwards, use the same red arrow as I did last time, and trace over this shape like this, and then put your pen on the center of rotation. Well, again, it's the origin, so I'm going to put my red dot there, and this time it's 180 degrees clockwise. Well, actually 180 degrees is a half turn, so it doesn't matter whether you go clockwise or anti-clockwise, you'll end up at the same place. But I'll do as I'm told, and I'll go clockwise. So that's a quarter turn, that's a half turn. So my red arrow should be pointing directly downwards, as you can see, and then I will make my marks using my ballpoint pen. Press hard, and then, just to be absolutely sure, lift the paper up gradually as I'm plotting the points to make sure that I'm getting it right, and then join up those points. So it's going to look like that, this, and then that's going to go to there. So my rotated shape is this one here. Okay, let's look at one more example of a rotation. So we've got a big shape here, and we need to rotate this 270 degrees anti-clockwise about the point 2, 1. Where is the point 2, 1? Well, that's 2 across and 1 up. Oh, the point is actually on the side of the shape. That's 2 across and 1 up. And we want to go 270 degrees anti-clockwise. Right, same procedure, tracing paper. Then I'll take my black pen and trace the shape. And then mark where the point of rotation is, 2, 1, it's right there. And then I'm going to draw a red arrow so that I know when I have done the amount of turn that I need to. So 270 degrees is 3/4 turn anti-clockwise, that's that way round to the left. So let's see how we go. Okay, pen in the center of rotation, and we want to go 270. So there is 90, that's a quarter turn. There is 180, that's a half turn. And then we want to carry on to 3/4 of a turn so that my little arrow is pointing to the right, and I reckon it's right there. Now I know all the points are exactly on the intersections of the grid lines, so I'll make sure that I put my dots at those points there, and then very carefully just double check that I've got them in the right place. Yes, yes, and there. And then I can join them up. So I go right across to here, down to here, across, up, across, and down here. So that is what my rotated shape looks like. So remember, have a go at the online exercise, but copy the diagrams onto squared paper Do them on the squared paper and then copy your answer back to the screen. Press the check button regularly and I'll see you back here for level 4. And the fourth transformation is an enlargement. So in this case, we're going to have to do an enlargement with a scale factor of 2. That means all the lengths of the sides are going to be twice as long, 2 times as long. And we're going to do it with this as the center of enlargement. So that's a bit like if we had a torch at that point there and shone it to all the points of the shape, it would be where the shadows would end up, I guess, if the image was of a scale factor of 2. So let's have a go at this. Let's put the point 1 minus 1 in first. 1 across, 1 down. That is the center of enlargement right there. So this is how you do it. I can see that from my center of enlargement, this top right point at the moment is 1 across and 1 up. So I want to double that because it's a scale factor of 2. So I'm going to go 2 across and 2 up and put a dot there. That's that top point, and that's the image of that point. Now this point here is just 1 square to the right of our center. So I want to double that and go 2 squares to the right. So I'm going to end up here. And then I want to look at this point here on the shape, which is 2 squares to the right of our center. So I want to go 4 squares to the right of our center. And it's always perhaps a good idea to, as you're going through, join up the points so that you're getting an idea of the shape. So this bit here is this bit here, but as you can see, it's twice as big. All the lengths are twice as long. So let's look at this bottom corner of the shape. It's 2 squares to the right and 1 square down. So I want to double that. 4 squares to the right and 2 squares down. And that will be here. Then this bottom left corner is 1 to the left, 1 down. Double it. 2 to the left, 2 down. Right, the bottom of the shape is here. Let's just check. It should be twice as long as that line. Well, that line is 3 square units long. So this one, 1, 2, 3, 4, 5, 6. Yes, we've got it. And we know that this left side is 2 units long, so our left side here is going to be 4 units long. And then join up. And that big shape there is the enlargement. And that's how you do enlargements. So let's have a look at another example. Show the image of the shape after enlargement of scale factor 2 again. And the center enlargement is minus 5 minus 5. That's right down here, isn't it? Minus 5 minus 5. 5 to the left, 5 down. So now we'll do the same routine. Let's start off with the top left vertex of our shape. I can see that it is 3 squares to the right and 5 squares up. So I'm going to double that and go 6 squares to the right and 10 squares up. So that point there is there. And to check, I could draw a straight line from the center of enlargement going through that top left corner, and it would just be twice as far. So let's put a little dotted line up to there and show you that if you go twice as far, you end up there. Right. Okay, now let's look at the top right point there. That top right point is 5 squares to the right and 5 up. So we want to double that and go 10 squares to the right and 10 up. So it'll be here. So the top of my enlarged shape will be right there. Then this point here is 5 to the right and 2 up. I'm going to double that, 10 to the right and 4 up. It's going to be here. So I'll draw the line down here. You'd use a ruler and a sharp pencil. And just to check that I'm on the right lines, just see if my little imaginary beam of light that is coming from the center of enlargement will end up. Yes, it will. It's right there. So it looks like I'm getting it right. Okay, this point here, from the center, 3 across and 2 up, double it, 6 across and 4 up. It's going to be here. So this must be the bottom of the shape here. And because I know the shape is twice as big, I know this line is going to be twice as long. This line is going to be twice as long. And that is going to be twice as long as well. So my image looks like that. Let's have a look at another example. Okay, this one we have a scale factor of 3, about 0.22. So it's another enlargement. Scale factor 3, about the 0.22. So let's have a look at 2, 2 is right here. And this time it's a scale factor of 3. So you know the routine. Let's start off with the top right point. It's 1 across and 1 up. We'll multiply that by 3 and go 3 across and 3 up. It's there. And then this point here is 1 across and 1 down, so we'll go 3 across and 3 down. It's here. And then let's just check, is this line 3 times as long as this line? 2, 4, 6. Yes, it is. So that must be the right-hand side of the shape. So you could carry on looking at the points, or, as we know this right-hand edge here, and we know that each of these are going to be 3 times as long, you could just draw it by inspection of the original drawing. That one will be 3 times as long going down. This one is already 2, so we need to make this one 6. And remember, you use a nice sharp pencil and a ruler for this. And then that one is 3, so this one is going to be 9. So this line will end up way up at the top there. And now I can finish it off. So my enlargement looks like that. And the last example for this level. Show the image of the shape after an enlargement, another enlargement, with a scale factor, oh my goodness, -1. And the center of enlargement is the origin, 0, 0. So the center is there. So what we have to do is exactly the same as we did before. So this point here is 2 to the left and 1 down. So we multiply those numbers by -1. So if you multiply 2 to the left by -1, you'll get -2 to the left, or 2 to the right. And instead of going down 1, if you multiply that by -1, it's going down -1 or up 1. So it's there. So that point ends up there. That's interesting. So this point here, 1 to the left and 2 down, multiply those by -1 is just the opposite really. It is 1 to the right and 2 up. So it will be there. Now this point here from the center of enlargement is 1 down. Multiply that by -1 and you'll get -1 down, which is 1 up. So it looks like that. So we've done those 3 points. Let's do this one here. From the center of enlargement, it's 3 down, 1 to the left. So we're going to go 3 up and 1 to the right. It is there. Now this one here is 1, 2, 3, 4 down and 3 to the left. So we're going to go 4 up and 3 to the right. Now this point here is 2 to the left and 2 down. We'll go 2 to the right and 2 up. So that's going to be there. And finally, we join up with that one there, which we've already plotted. So this time, that's what you get when you enlarge something by a scale factor of -1. So really, that word enlargement in maths is a little bit different to in everyday use, because that you wouldn't say that was an enlargement, but in maths it is. It's an enlargement with a scale factor of -1. So it looks like it's the same size, but the orientation is different. Okay, have a go at the online exercise for level 4, and then come back here for level 5. Now, most people can skip this level 5 because it probably isn't on your syllabus. Do check, are matrices on your syllabus, matrices used for transformations? Probably not, but I'm going to show you how to do it for those that are interested. What we have to do is transform this shape using this matrix here. So the way we do it is we start off by writing down the matrix that we are going to use. And what I'm going to do now to make things a little bit more clear is I'm going to label the points of this shape. So I'm now going to make another matrix with the coordinates of these points. So A is -2, -1. So I'm going to write -2, -1. And then B is at 0, -1. That's the point B. And then C is at 0, -3. And then D is at -1, -3. E is at -1, -4. And F is at -2, -4. So I've got a huge matrix there containing the coordinates of all of the points. And now we use matrix multiplication. We multiply this matrix by that matrix in order to find out the coordinates of the image. And what we'll get is another matrix like this. It's going to be just as large as that second matrix there, and it's going to give us the coordinates of these points after they've been A, B, C, D, E, F, after they've been transformed by the matrix. So let's see. The way I like to think about this is we're going to multiply the top row of the first matrix by the first column of the second matrix. 0 lots of -2 is nothing, and then -1 times -1 is +1. So the first number there is a 1. And then I'm going to multiply the second row, this will stay still, by the first column to get the y value down here. So 1 times -2 is -2, and then a 0 coming from this multiplication here. So that's -2. Then I'll move that across and that up. So multiply this row by this column. So 0 times 0 minus 1 times -1 is +1. Then move that down. 1 times 0 is 0. 0, that's 0. And move that across and that up. So now I know the coordinates of the image. So what I can do now is plot those coordinates and join them up. So A maps to A dash or A prime, whatever you like to call this little dash here, and it's at 1, negative 2. So that'll be 1, negative 2. It'll be there. Then the image of B will be at 1, 0. That's 1 across and 0 up. So I can join that line there. Then I go to 3, 0. 3, 0 is here. 3 minus 1 is here. 4 minus 1. 4 minus 1 is here. 4 minus 2 is going to be here. So what sort of transformation do you think that is? Well, to me, it looks like a rotation. It looks like a rotation of 90 degrees. And because it's going in the anti-clockwise direction, I'm going to say it's a rotation of positive 90 degrees. And the center of rotation looks to me as if it is the origin right there. And that's how you do transformation using matrices. So have a go at level 5 and then come back here for level 6. And here's an example for level 6. What are the coordinates of the point 4, 1? Oh, I'll draw that. 4, 1 is here. After it has been reflected in the line x equals 2, I know what that looks like. It's all the points that have an x coordinate of 2. So I'll draw that with a red line here. And we need to reflect that point in the red line, so it will end up here. And then it is rotated 180 degrees. That's a half turn, so it doesn't matter whether it's to the right or to the left, clockwise or anti-clockwise. We're going to go to the same place, about the point 2 minus 2. Where's that? 2 minus 2. So that is the center of rotation. 2 minus 2 is right there. We need to rotate that point. I could use the tracing paper. And as it's only one point, it's not too difficult to do. So I'll go over the point. I'll put a little vertical line here so I know when I've done my half turn. I'll put the pen in the center of rotation and I will go for my half turn, and it looks like it's going to end up right down here, which is the point 4 minus 5. 4 minus 5 is the answer. Okay. I suggest you make diagrams on paper to help you do level 6, then come back here for level 7. So when you get to level 7, hopefully you've done the other 6 levels, and level 7 is a bit like working backwards. We have got the answer and we've got to work out what the question was. So for example, a question at level 7 could be, what transformation maps shape B onto shape C? And I can see from my experience of doing the other levels that if I had a mirror line along here, that line would be the line that B could be reflected in to give you shape C. So that's one way of transforming B to C. There may be other ways. Okay, now it's your turn to have a go at the online exercise. Don't forget to claim your trophy when you've got to the end. And there are lots more activities on the Transom website for you to have a go at to improve your mathematics, and you can claim hundreds of trophies. So, what are you waiting for? Get going! Bye!
You can find Transum Mathematics at www.transum.org, where you're welcome to use all of the activities absolutely free, or jump in with both feet and become a Transum subscriber.